In this lecture, we talk about Fibonacci search, which is a search algorithm on a sorted array. Previously, we have seen binary search and interpolation search. In case of binary search, progressively always the mid value of the array is found and suitable subarrays are narrowed down. In case of Lagrangian search, the subarrays are progressively divided based on the interpolation formula, based on the location of the value in the subarray. Now, in case of Fibonacci search, we identify the subarrays based on the Fibonacci numbers. So this is a specialty of this, and the Fibonacci sequence actually has a specialty that the ratio between successive values is always constant, which is called a golden ratio. It's called 1.615, something like that, which approximately divides into one third and 2/3 ratio for any given array. So based on this Fibonacci sequence, we progressively divide the given array into smaller and smaller subarrays to identify the key value. Fibonacci sequence is one of the widely studied sequences in history, and interestingly, it is applied to the nature very widely, and so many aspects of nature are following this Fibonacci sequence. You can observe from the diagrams here that the petals of the rose, actually the ratio between the successive petals of the rose follows this Fibonacci sequence. And similarly, the storm, when it is rotating, the shape of this is also, the ratios of the different layers of the storm are also identified to form a Fibonacci sequence. Basically, just for the new observers, the Fibonacci sequence is simply initially starting from 1 and 1, and the successive numbers of the Fibonacci sequence are generated by adding the previous two values. So 1, 1 are the starting values, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, so on. So here a sequence is given and the equation is given as Fn. The nth term of the Fibonacci sequence is the sum of the previous two numbers of the Fibonacci series, Fn minus 1 and Fn minus 2. This is basically what the Fibonacci sequence is. Now, if you look into the procedure, if k is the given key value to be found in the array, given sorted array, the idea is first we find Fibonacci numbers, which is the smallest Fibonacci number, which is greater than the size of the given array. If n is the size of the given array, then we'll try to find out the smallest Fibonacci number, which is greater than n. Now, once that number is found, the previous two numbers will also be found. Fib1, Fib2, Fib3 will also be found. And based on Fi minus 2, that means a third Fibonacci number, we can, treating this as an index actually, we use that as an index. And based on that index, we compare the element of the array with that index with the given key value. If the key value is greater than that, we concentrate on the right part. If it is less than that, if we concentrate on the left part. And if it is equal to that by incidentally, then we follow that, identify the key value. So basically, the given array will be divided into two parts, 1/3 and 2/3. So we always will try to identify in which part the key value lies progressively. Now we talk about Fibonacci search algorithm. The input to the algorithm is the array itself and the size of the array and key value k. By chance, if n is equal to 0, that means no array is given and return just -1, nothing to be done. Otherwise, initialize three values, the Fibonacci three values, initial values, as Fib1 is 1 and Fib2 as 1 and Fib3 has some of the previous values, Fib1 plus Fib2, so Fib3 is also 1. Now, once we initialize this, using a while loop, recursively add the previous two values of Fib1 and Fib2 and compute Fib3. Until Fib3 just crosses n. So keep on incrementing Fib3 based on this formula. Fib3 is equal to Fib1 plus Fib2, and until it just crosses n value, so that it becomes the smallest Fibonacci number which is greater than n. So fib3 consists of that number. Once we do this, we initialize two variables. One is offset and another is I to indicate the current and previous split points to indicate them. So set that offset value to be -1 initially, and I will be computed based on this offset value and fib2 values. Now we use Fibonacci numbers now, starting with fib3, which is the smallest Fibonacci number, which is greater than n. We're starting with this fib3, while fib3 is greater than 1, because we may start fib3 at some location based on the size, but gradually will come down to in the Fibonacci numbers, we may come down to 1. So while fib3 is greater than 1, compute the index I as minimum of offset plus Fibonacci number 2 plus comma n minus 1. Whichever is smaller, we'll pick up that, and that becomes the split point. Actually, I is the split point. Once we compute the split point based on the offset, that means the previous split value, initially the previous split value is set as -1, and based on fib2, we are going to identify the split point I. Once we compute this, then we compare the array value at that location of I with the key value. So if array of I is less than k, we need to do something. Else if array of I is greater than k, we need to do something, right? If it is equal, then just we can return, nothing else to be done. Now, if array of I is less than k, then the Fibonacci numbers are gradually decreased by one step. So fib3 is read as fib2, fib2 is read as fib1, and fib1 is computed as fib3 minus fib2. And set the offset value now shifts to I, so that the left 1/3 part is discarded, only the right 2/3 part remains. This is one way. Else if it is not the case, if array of I is greater than k, that means key value is less than array of I, that means key value lies in the left subpart of 1/3 part. Then what we are doing is we are skipping these Fibonacci numbers 2 steps down, so that fib3 becomes fib1, fib2 becomes fib2 minus fib1, and fib1 becomes fib3 minus fib2. Else return I, which indicates if it is equal to k. Array of I is equal to k is else actually here, and if it is the case, just return I. So we keep on doing this. That means in either of the case, what we are trying to do is we are trying to find out the split point. Once one iteration is done, then fib3 value is updated. Once this iteration is done, we will go back to while loop, and fib3 is again, the new fib3 value is compared with 1. Either in the first case fib3 is fib2, or in the second case fib3 is equal to fib1. In either of the case, it will be compared with 1. While fib3 is greater than 1, again we'll recompute I as minimum of new offset value plus fib2 comma n minus 1. So iteratively we keep on doing this until the subarray size is reduced gradually, and in the lower case where the subarray gradually decreases, two cases may arise. Either fib2 is equal to 1 and array of offset plus 1, the location of the offset plus 1 may be equal to k. If these two occurs, then the array consisting of value at offset plus 1 will be the key, because gradually we are narrowing down and we will reduce this to either one value or at the most two values. If it is one value, it returns I in the above case. If it is consisting of two values, in this case fib2 becomes 1 and array of offset plus 1 will be the key. So until such time, using Fibonacci numbers, we gradually divide the array into smaller and smaller parts. Now we look into an example here consisting of 12 values in an array, sorted array. The first we compute the smallest Fibonacci number which is greater than the size of the array. Size of the array is 12. So 13 is the smallest Fibonacci number which is greater than 12. So Fib3 is set to 13, Fib2 is set to 8, and Fib1 is 5. The successive Fibonacci numbers in the sequence. Initially we set the offset as -1, and we compute I, the split point, as minimum of -1 plus Fib2, 8, comma 12, size of the array, and -1. Then I value is 7. It becomes this split point, new split point. So we compare the value at A of 7, which is 88. Incidentally, 88 is greater than 36, so 36 lies to the left of 88. Now we need to concentrate only on the left side of 88. That is the first breaking of the subarray. Once we do this, as per the algorithm, since it is on the left side, we lower the Fibonacci numbers by 2 steps. So Fib3 becomes 5 now, because after 13, if we move 1 step down, it is 8, but if we move 2 steps down, Fib3 becomes 5, Fib2 becomes 3, and Fib1 becomes 2, the successive Fibonacci numbers. By using these Fibonacci numbers in the second iteration, we compare Fib3 as 5 is greater than 1. Then again we recompute the index I as minimum of -1 plus Fib2 as 3, 11, which is 2. So the new split point in the subarray is 2, and A of 2 is 29, again compared with 36 key value. This time key is greater than 29. Again, by the algorithm, if key is greater than that, we move down in the Fibonacci numbers by 1 step only. So Fib3 now is 2, Fib2 is 2, and Fib3 is 3, and Fib2 is 2, and Fib1 is 1. So offset, now here offset is changed to I. New offset is 2 in this case. In the third iteration, again Fib3 is 3 compared with 1, which is greater than 1. So it goes into the while loop, and I is recalculated as minimum of 2, offset plus Fib2 is 2, 11, so which is 4, and the new split point is 4 now. A of 4 is compared the 47, which is greater than 36. So 36 is to the left of 47. Again, by the algorithm, we have to move the Fibonacci numbers 2 steps down. Once I do that, what happens is Fib3 becomes 1, Fib2 becomes 1, and Fib1 becomes 0. In this case, Fib1 has become 1. So if we go to the while loop fails. While loop condition fails. So it comes off the while loop, and the last condition is checked, that A of offset plus 1 is A of 2 plus 1, which is A of 3, coincides with 36, which is the key value. Since it is matching with the key value, return the index as 3. Now we observe one more example here. The key value is 101 in this case. The size of the array is again same array is taken here. In the first iteration, the smallest Fibonacci number is 13, and Fib3 is 13, Fib2 is 8, and Fib1 is 5, and offset is -1. Now we compute I as a minimum of offset, -1 plus 8, 11, so that becomes 7. The new split point is 7. A of 7 is 88, which is less than 101. So 101 lies in the right sub array. As per the algorithm, we move down the Fibonacci numbers 1 step. So Fib3 is adjusted to 8, Fib2 is adjusted to 5, and Fib1 is adjusted to 3. But offset is moved to 7 because we are focusing on the right subarray. In the second iteration, Fib3 is 8, which is greater than 1. Again, we recompute I, minimum of 7 plus 5, 11, which is 11 now. And A of 11 incidentally is 124, which is greater than 101. So the required key value is to the left of the index value at the index. Then as per the algorithm, we have to move the Fibonacci numbers 2 steps down. That is why Fib3 becomes 3, Fib2 becomes 2, and Fib1 becomes 1. In the third iteration, Fib3 is again greater than 1. So we recalculate I as minimum of 7 is the offset now. 7 plus 2, Fib2, which is 9. And incidentally, in this case, A of 9 coincides with the key value, so 9 is returned. When it comes to the best case, average case, and worst case, best case is one where in the searching process, once the Fibonacci numbers are identified and the index is calculated, the first index value where we are computing, if it is itself consisting of the exact key value in that location, then it becomes the best case. Only one comparison is done with the key and comes out. So that becomes the best case. And worst case occurs when the target element is always present in the larger subarray, because every time we are dividing into two parts, the 1/3 and 2/3 part, if the key value lies in the 2/3 part, so gradually we have to move towards the 2/3 part and it becomes the worst case. In the average case, of course, which is when the key value lies in the 1/3 part, always if it is lies in the 1/3 part, minimum number of comparisons are required in the average case.